And because everyone doesn't have access to a TI 80 TI Inspire, we are learning how to do it via Desmos. So I hope that makes sense. So it's pretty easy. It's very similar to how we did it with the linear equation. The only thing is different is what we're typing into Desmos. All right, so our main big idea is how can you create a quadratic equation given at least 3 points? The key thing here is with linear equations, we needed at least 2 points. With quadratic equations, we need at least 3 points. Okay, so the steps that we're going to use are 1, we start a new blank graph. 2, we create a table. 3, we input the values into the table. And 4, we're going to type in box 2, we type the following thing. 1, I'm going to call it a squiggle line for the, I just had a brain fart on what the actual this thing actually is called. 1y, and then ax1 squared plus bx1 plus c. And so we're going to type that in, and then we press enter, and it's going to tell us our a, our b, and our c, and we're able to write our quadratic equation from there. All right. Sounds simple enough? Sounds simple enough, right? So let's navigate on over to Desmos so that we can do the first problem. So the first problem, it gives us 3 points, and our 3 points are what our table is going to be made of. Okay, so our table is going to be made up of 0, -2, -1, 5, 2, 2. So we have 0, -2, -1, 5, 2, 2. Okay, so let's go to Desmos. All right, let me see. So I'm going to Desmos, graphing calculator. And I'm going to, it's already set for a new graph, but if it wasn't, then I would go there. So I'm going to add a table. And in my table, I'm going to put in my values that I have: 0, -2, -1, 5, 2, 2. And then I'm going to type in the what my y needs to equal. So we're going to type in y. And to get the sub 1, we use the underscore key. So we're typing in y_1 equal, not equals, squiggly line, a, and we need x underscore 1, and but it's squared. So underscore to make the 1, the caret, which is on 6, to make the 2, plus bx underscore 1 plus c. And we're done. So it tells me what my a equals, what my c equals, what my b equals. And if I know my my ABC, can I write my equation? Why, yes, I can. So we have A equals 3, B equals -4, and C equals -2. So we're going to go back. So for my calculator steps on Desmos, we ended up with A equals 3, B equals -4, and C equals -2. And we're writing it in Y equals AX squared plus BX plus C form. So that gives me 3x squared minus 4x minus 2. How do we feel? Pretty easy? The power? Or the... Okay. So putting in the table, we're good. This part? Okay. So when you're typing in this part, to get the 1 as a subscript, you're going to hit, put in the underscore, and it turns it into a subscript. And then it's the squiggle line that for some reason I can't tell you the actual name of. And it's your AX squared is what you're putting in. So AX, but it's X1 if you look at our table. So we put underscore 1. And you either can press the square or open the keypad and press the square to make it X squared. Underscore is shift and then the button next to 0. Oh, you're fine. Plus BX underscore 1 plus C. Now, the beauty of this is that using Desmos, once you've done it one time, when you're going on to your next problems, if you just change the table, it'll change what's given below. So if we look at example 2 in our notes, so example 2, we have the soccer player kicks a ball, should be off the top of a building. His friend records the height of the ball at each second. Some of her data appears in the table. So what is a quadratic model for this data? So our 3 points that are given are 0 and 112, 1 and 192, and 5 and 192. So I'm going to put that information in. But notice, once this table is open, if I just change what needs to be changed, it'll modify the graph and modify the values. I have to zoom out a lot. But there is my equation, my values. So now I know what my A is, my B is, and my C is. So from plugging this in, we have that A equals -16, B equals 96, and C equals 112. So I'm going to go to so when I write my equation, I have all the values I need. So again, we had A equals -16, B equals 96, and C equals 112. So therefore our equation Remember, we're in standard form, y equals ax squared plus bx plus c. So that gives us negative 16x squared plus 96x plus 112. And it wants us to fill in the rest of the table. So where was the ball at 2 seconds, 3 seconds, 4 seconds, 6 seconds, 7 seconds? So you can click along the graph. That's a feature. You can, so if I'm looking for 6 seconds, I can, 6 was 112. I can find 7 seconds. And where was I at 7 seconds? 0. I can look for 4 seconds. So again, all I'm doing is taking my cursor, clicking and hovering it over the graph. Four seconds, I was at 240. 3 seconds, I was at 256. That's my vertex. And because that's my vertex, at 2 seconds, it should be the same as 4 seconds, right? And at 2 seconds, I was also at 240 feet. So filling in the rest of the table, I was able to complete it. So we have 2 seconds, it's 240. 3 seconds, 256. 4 seconds, 240. 6 seconds, 112. 7 seconds, 0. So this guy is my vertex. That was the highest I was at. And this means I am back on the ground. All right, that is modeling with quadratics, quadratic regressions. Any questions, comments, concerns, anything you need me to reiterate?